Hi guys, welcome to Electronics Class Tanzania and Happy New Year 2024. Your coach Engineer Mhina again present to you a subject about maximum power transfer theorem. In a circuit, whenever you have a source and you have a load, the power is normally transferred from the source to the load. And when you need to have a maximum power transfer in a circuit, there are one major scenario which must be met, which is the load resistance should be equal to the internal resistance of the source. And this is a theorem of maximum power transfer, which states that a source load should be made equal to the internal resistance of the source. And this applies also to the DC, also to the AC circuit. And here we have a circuit which is, we have here a generator, and we have internal resistance, we have current, we have load resistance. And here this is the graph of maximum power transfer. We have power output, the function is load resistance. Then whenever we have a load resistance made equal to the internal resistance of the source, then we have maximum power transfer. The formula for the current in the circuit is voltage over summation of internal resistance of the source and plus the load resistance. Power is I square load resistor, the power at the load, which will be delivered according to the formula. The application of maximum power transfer. Maximum power transfer is very essential on electronics circuits, but in electric power systems, example in a grid power transmission, it's very hard to have maximum power transfer because of the low efficiency and a large loss in between from generator to the load. There is big loss, so you can't get this a maximum power transfer. But in electronics circuits, we need maximum power transfers. Is very essential. For example, in an amplifier and a speaker. Speaker is a load and amplifier is a source. We need a maximum power transfer. Let's see mathematical proof of our theory of maximum power transfer. We have two scenarios. The first one is when load is made equal to, when load resistor is made equal to the internal resistance of the source. Here we have a generator which have 200 volts and internal resistance of 100, and the load at the first case, the load is 100 ohms. At this scenario is maximum power transfer because of the internal resistance equals to the load resistance of the circuit. So we want to see how the power generated and the power at the load. In order to get power, the form of the power is equal to I square R. This is the formula of the power. So we have to calculate current in our circuit. The formula of the current is here. So at this first scenario, we have to find a current. Current is equal to, the voltage is 200 over, load is 100 plus internal resistor of the source is also 100, so we have 200 over 200, we have 1 ampere. So to have power at the source, let's find the power at the source. Power at the source in this circuit is equal to I square R, but R is the total resistance of here and here. R internal plus R load. Then we'll have power at the source. Therefore, we have 1 square, which is our current, and internal resistance is 100, plus load resistance is 100, is 200. Therefore, we have 200 wattage. So the power here is 200 watt at the first scenario. And let's see power at the load. We are using the same formula. Our current is the same, 1 square, and the load is 100 because it is RL. So it's 1 square times 100. So we'll have here 100 wattage. So the 200 watt generated, we get the output of 100 watt. So the efficiency here is 50% because efficiency is equal to power out over power input. Power output over power in, that's the efficiency. Our power output is 100 over, our input power is 200, so it's a half is equal to 50%. This is the efficiency. This is the efficiency of maximum power transfer. So we see here that efficiency is not so good, but the power transferred is large. Let's take an example of a second scenario when load is not equal to the internal resistance. The load is 300 ohms. What we will get? So let's go to the second scenario when load resistor is equal to 300 ohms. Current. This is our formula of the current. The circuit is the same, but we just change the load resistance. So the same voltage, which is 200, over load resistance is 300 plus internal resistance, which is 100. So here we have, I'm going to have 200 over 400, we're going to get 0.5 ampere. So this is the current. Is the current when we have a load resistor of 300 ohm. So the power, to have power, same formula, I square R. Power to the source is R internal plus R load. Our current is 0.5 square. So the resistor internal is same 100, but the load resistor is 300. So here we have 400. So a power at the source is going to be 100 wattage. So let's check the power at the load. Power at the load is the same formula. We have power at the load, 0.5 squared and times load resistance, which is 300, then we have 75 wattage. So when the load resistor is not equal to the internal resistance of the source, we see power 100 watt generated, and the output, part the load is 75. So the efficiency is 75%. We have high efficiency. High efficiency, but the power is small. So it depends on the situation and the scenario. As I said, in the electronics circuit, for example, in the power amplifiers, we need much of maximum power transfer. We don't care about efficiency. That's why in the first scenario, this first scenario here, when the load resistor is equal to the internal resistance of the source, the efficiency is 50%. But we have large power, which was 100. So in electronics, we care about maximum power transfer, and we don't care about efficiency. But in electric power systems, for instance, in the grid powers, we care much on efficiency because we can't get maximum power transfers because of the losses in between. Let's take a scenario or an example of an electronic circuit, which is audio amplifier. We have here audio amplifier, which has an output of 12 volts and the external resistor of 15 ohm. So in order to have maximum power transfer from this amplifier to the load, this load is a speaker. This is our speaker here. In order to have maximum power transfer from amplifier to the speaker, the load here should be 15 ohm, equivalent to the internal load of the amplifier, which is our source. This is a situation when we want to have maximum power transfer from amplifier to speaker. Let's take an example of AC generator. AC generator here has 50 volts and resistance of 100 ohms and inductance of 50 ohms. So the load, in order to have maximum power transfer, the load should be conjugate of the internal resistance. So the resistance is 100 ohms, but the load should be conjugate, then we have the capacitance of 50 ohms. So this is the impedance of AC generator. This is the impedance of the internal resistance. This is impedance of the internal source, the internal impedance of the source, which is 100 plus J50, and the impedance of the load is 100 minus J50 because it's capacitance and it should be conjugate of the internal impedance. So the total impedance, we sum up, this cancel each other, this one and this one cancel. That's why we have 200 ohms as total impedance. So current in the circuit here, our current is voltage, which is 50, source voltage, over total impedance, which is 200. We have 0.25 our current ampere. So power, our formula is power I square RL, the power at the load. Why we take only resistor, why we consider only resistor, is because this capacitance and this inductor doesn't consume power. And that's why we have seen here they have cancelled each other. So in our circuit, when we have to find a power, we just consider only resistance, because the either capacitance or inductor, this doesn't consume power. They're not consuming power. This is they consume no power. They consume no power. That's why when we want to find the power at the load, we just consider only resistance. And here we have 6.25 watt as our maximum power transfer at this scenario, at this situation. Hello guys, today we have learned about maximum power transfer, and we've seen the application of the maximum power transfer where it is applicable. We have seen in electronics that we need maximum power transfer because it's where we need power, real power. We don't consider efficiency, but we really need a maximum power transfer, and we have seen the example of the power amplifier and a speaker. But in contrary to the electric power systems, we just consider efficiency. That's why we don't care for maximum power transfer, because you can't get maximum power transfer because of the losses in between generation and the load. That's why we just consider in electronics maximum power transfer, like in power amplifiers and the speaker of seen. Because if we want to emphasize efficiency on electronics circuits, there will be some disadvantages of big equipment, because you have to connect in series many circuits, or in order to make use of big power in order to have maximum efficiency. But that's why we don't care about efficiency. We just consider about maximum power transfer. Next lesson, we continue to go deep about some electronic circuits, so don't miss, and don't forget to like, share, and subscribe Electronics Class Tanzania. Thank you for watching.